Now we're going to take time to review this unit to help you get ready for your assessment. So to begin with, let's talk about what we did in this unit. We talked about systems of equations, which is when you have more than one equation. You're trying to find the same x and y that fit in both equations, or on your graph where they intersect. So we looked at linear equations where we had two lines, linear and quadratic, a line and a parabola, a linear and a square root, a line and the swimmer's arm, quadratic and quadratic, quadratic square root, and two square roots. Right? Then we solved them by graphing, substitution, or elimination. But remember, elimination only works with linear. Okay? And it can be a very simple method to use, but it can only be done if you have two lines, two linear equations. Substitution is where you have to have one variable by itself. You isolate it, and then you plug it into the other equation. And graphing is where you look for the intersections. Right? And then we talked about some word problems where the challenging part is writing your equations, and then you solve using one of these methods. So elimination. Okay, again, it only works with linear, and so I have two lines here. They're already set up where x and y are on the same side. I need one variable to cancel, and I notice that 2y and negative 1y can easily cancel if this negative 1 became a negative 2. So if I multiply the entire bottom equation by 2, I bring the top equation down, and then I multiply everything by 2. So I get a 6x minus 2y equals 10, and then I can add. My y's are what's going to cancel. 4x plus 6x is 10x. 10 plus 10 is 20. To solve for x, all I do is divide by 10, so x equals 2. So in elimination, our goal is to eliminate one of the variables. I'm not done yet. This is only half of my answer. I take x and plug it back in. So I'm just going to pick an equation to plug it into. So if I plug it into the first one, I have 4 times 2 plus 2y has to equal 10. 4 times 2 is 8. Subtract 8 from both sides, and 2y equals 2. Divide by 2, and y equals 1. And then you write your answer as an ordered pair. So my answer would be 2, 1 with parentheses. For our graphing example, okay, now I've got a quadratic and a linear. Remember, whenever you go to graph, you need to have y equals so that you can graph in the correct form. So for the bottom linear equation, I need to add 1 to both sides. So then I get y equals x plus 1. Now it's in slope-intercept form. Remember, if there's no b term, if there's no x term in our quadratic, we can consider this to be vertex form. If I put my parentheses around the x, it's kind of like this is where my x minus h goes, and then my plus k is on the outside. So for this one, my h would be 0, and my k would be negative 5. So I have a vertex at 0, negative 5. I'm going to graph the line first, because it's a little easier. So to graph x plus 1, I'm going to go positive 1 on my y-axis. My slope is 1, so I'm going to go up 1, right 1. I'm going to fill up my entire graph just so I know exactly where my intersection is whenever I graph the parabola. And I'll connect those. And then to graph the parabola, I'll go 0, negative 5. And I'm just going to have to plug in points. And remember, the vertex is the middle of the graph, so whatever I do on one side, I can reflect it over to the other. So if I plug in a 1, 1 squared is 1, minus 5 is negative 4, and that goes on this side as well. Plug in 2, 2 squared is 4, minus 5 is negative 1, 2, negative 1. And there's going to be one of my intersections, so I'm going to keep going and see where it crosses again. If I plug in a 2, 2 squared is 3 squared is 9, 9 minus 5 is 4, and there's my other intersection. I can put that on this side. So whenever I connect my points to get my U shape, I see that I have two intersections. One is at 2, negative 1, and one is at 3, 4. So I have two solutions to this system, 2, negative 1, and 3, 4. And the last method we looked at was substitution. So substitution is where you have to have one variable isolated, and then you're going to plug it into the other equation. For this example, I have a square root and a line, and the square root's already got y equals, so I can take whatever I know y equals and plug it into y in my second equation. In this case, they're both set to y equals, so I'm just going to end up setting them equal to each other. So I have the square root of 3x plus 1 equals 3 minus x. I have a radical equation, so I'm just going to square both sides to cancel out that radical. But remember, this is a binomial, and if I have a binomial squared, I'm going to have to FOIL. The left side becomes 3x plus 1. I'm going to FOIL 3 minus x off this side. Come on this side. So that's 3 minus x times 3 minus x. 3 times 3 is 9. 3 times negative x is negative 3x. Negative x times 3 is negative 3x. Negative x times x is x squared. Combine my like terms. So I have 9 minus 6x plus x squared. And then I'm going to go ahead and write it in standard form. Put my biggest exponent first. So that's the positive x squared. Then my negative 6x term. And then the positive 9 at the end. So I have 3x plus 1 equals x squared minus 6x plus 9. And now I have a quadratic, because that x squared, so to solve a quadratic, I have to set it equal to 0. So I'll subtract the 3x over, subtract the 1 over. So I'll have 0 equals x squared minus 9x plus 8. Remember, you can solve a quadratic by factoring, graphing, quadratic formula, or completing the square. This one's easily factorable, so I'll skip straight to parentheses. I need numbers that multiply to negative 8 but add to negative 9. And that would be negative 8 and negative 1. So x equals 8 and x equals 1. Remember, there's only half of my answer. I've got to plug it back in and find the y. So I'm going to plug it into the linear equation. If I have that option, I'm going to choose the linear just because it's a little easier to plug into. So y equals 3 minus, I'm going to plug in an 8. 3 minus 8 is negative 5. So that means one of my answers is going to be 8, negative 5. I'm going to do the same thing with the 1. So y equals 3 minus 1, and 3 minus 1 is 2. So my answer is going to be 1, 2. So one thing to keep in mind, you got to remember what your graphs are going to look like, right? So if I were to think about this graph of the swimmer's arm, I know my h value is going to be a negative. I know it opens up, and it's going to look something like that. I know that this equation is really negative x plus 3, so it's going to go up at 3 and go down 1 over 1. Well, when I sketch that, I see that there's only one solution. Okay, remember, with any type of radical equation, you've always got to look for an extraneous solution. So if I plug both of these back in, if I plug in 8, negative 5, 3 times 8 is 24, plus 1 is 25. The square root of 25 is positive 5, not negative 5. So this one doesn't work. If I plug in the 1, 2, 3 times 1 is 3, plus 1 is 4, square root is 2. So my answer is actually just 1, 2. Make sure you always think about what your graph is going to look like. Use what you've learned about graphing linear, quadratic, and square roots to be able to visualize what your answer is.